This part of chapter 1 is going to talk a little bit about measurements and the type of units that we're going to be using in class. So let's get started. So measurements are important because this is going to be something where we're expressing something with a number or a magnitude and a unit. Because it turns out just the number by itself really doesn't have a lot of meaning. For example, if you're looking at the length of something and say it's 165, it's 165 what? Centimeters, inches, feet, yards, miles? Who knows? So you have to have some sort of a unit. Now, the unit is just something that you're able to compare it against. So that's what talks about a standard unit, a fixed and reproducible value for the purpose of taking accurate measurements. So if you're going to find the length of something, you would compare it against a ruler, and that ruler could be measured in inches or it could be measured in centimeters. Um, Now, what you can do is take all these individual units and combine them together within a system. Now, the two most common ones that we talk about are the English or the standard system. That's what most of us grew up learning, and the metric system. Now, we're going to look at a special type of the metric system called the SI system. Now, I know we're still mostly familiar with the English system, but the English system has some disadvantages. Now, it was originally based on inexact physical measurements. For instance, a foot was the length of a man's foot. Now, originally it was based on the physical proportions of King Henry I. So, like a yard was the length from the tip of his thumb to the tip of his nose. Now, it turns out I have short arms. So, for me, a yard would be from the tip of my thumb just past my nose. That would be a yard. But if I held up a yardstick, I could actually measure to see how close or how far away that is. So over the years, this has been standardized. Let's see here, another couple ones I like. Ooh, an acre. An acre was originally defined as the area tilled by one man working with one pair of oxen in one day. Volume was based on a row, and row was defined as a mouthful. 2 rows equal a jigger. Now, does that sound familiar? I'm hoping it doesn't, but as you age a little bit, maybe you get into mixing drinks for a party. A jigger is actually a measurement that's used for alcoholic drinks. Again, not trying to encourage any drinking going on here, just stating this is where you may see something like this. Um, the US is the only large industrialized country that still uses the English system, and the main disadvantage is it's kind of a pain to convert between things. Now, we could talk about some of the advantages or the difficulties of transitioning. I guess that's more of a better way of putting that. Um, but the main disadvantage is it's kind of a pain. For instance, how many inches are in a foot? 12. How many feet in a yard? Oh, yeah, that's 3. How many feet in a mile? 5,280. So it has to be like you have to memorize all these random facts that you have. The metric system, as we're going to see, is much easier to convert between. Now, this particular slide is just going to go over some just brief history of the metric system. It was originally talked about in the late 1600s, but it wasn't until the late 1700s that it actually came to be. And it was actually the French who really had the metric system. Now, I've heard stories about how Thomas Jefferson actually considered it for the US because, I mean, if you think of the late 1700s, that's when we gained our independence. And by golly, we didn't want to be like England at all at that point in time. But one of the things I've heard is that the prefixes that they used were different depending on what value you were looking at. And so it got very complicated. Now, the US does have the world's first decimal based currency system, though. 100 pennies in a dollar, 10 pennies in a dime, all sorts of stuff like that. Um, let's see here. In 1893, the US officially adopts the metric system, but it still continues to use the British, the English, the standard units, whatever you want to call them. And in 1975, the US had what was called the Metric Conversion Act those created by Congress, saying that we are going to switch to exclusive use of the metric system. This has not happened, but if you read at the very end, it says that there is no mandatory requirement. So if I tell you you have an essay that you need to write, when do you actually start that essay? I mean, for myself, I'll think about it. I might even start working on it just a little bit. But for me to get really serious about it, it's usually right before the deadline. I'll admit I am a procrastinator. And so that's what ended up happening with this. I remember as a kid, they started doing a lot more dual measurements, like on the road signs, it would give the mileage in miles and then also in kilometers. Um, but that kind of went away. So I don't know. It would be useful, but my kids are still learning with the English system also. So we have 7 base units that we use for whatever system it is that you're looking at. And again, we're going to be talking about the SI system, which is a variation of the metric system. The first thing we have is mass. Now we're going to show that mass, we're going to measure mass in kilograms. We're going to learn about that here over the next few slides. Length is measured in meters, and time we're going to measure in seconds. Electric current is measured in amps. Temperature is measured in Kelvin. So that one, Kelvin, is actually the absolute zero scale where you have no negative numbers, which is very, very convenient. The amount of substance is a mole. We'll talk about that a lot in chemistry. And luminous intensity is based on a candela. Now, the very first one we want to talk about is length. We measure that in meters, and length is just defined as the measurement of space in any direction. So width is the same as length, it's just in a different direction. That's why we don't list it out separately. Now, if you go grab a yardstick or a meter stick, whatever you have, you'll find out that the meter and the yard are really, really close to one another, but the meter is ever so slightly longer than a yard, about 3 inches. So remember when we were talking about the yard, the distance from the tip of the thumb to the tip of the nose, I have short arms, my meter is going to be a little bit longer. Now, I've held that meter stick long enough. I'm pretty good at measuring out where that's going to be based on my physical dimensions. Now, when a meter was originally defined, they said, okay, we're going to take the distance from the North Pole to the equator, and we're going to divide that distance into 10 million units. And each of those units is a meter because they wanted something that was reproducible and based on physical phenomena. The problem is the Earth is not completely round and it's kind of squished just a little bit. So then what they did is they said, okay, let's use the distance that light will travel in a very, very, very small fraction of a second. And so that's actually what the meter is defined as today. The distance that light will travel in a vacuum in a very, very small amount of time. It's 1 over, has a down over here is how small of a fraction of a second you're going to go. Now, kilogram is kind of unique. So this is our mass. Mass is defined as the amount of matter an object has. Mass is always constant, so it doesn't matter if you're here or in the moon, on the moon, not in the moon, on the moon, in a spaceship, wherever you might be, mass is constant. Now, your weight will change, but weight is actually the gravitational force acting upon a body, as we're going to see whenever we get into forces later on in this unit. So weight changes. Weight is not a fundamental quantity, but mass is. Now, the British system uses the slug, which is absolutely a hilarious name if you ask me, but yeah, a slug. But for the metric system, the SI system, we're going to use the kilogram. And this is one reason that the SI system is a little bit unique. It's not the gram, it's actually the kilogram. Now, kilograms about 2.2 pounds, so if you can kind of imagine how much that's going to be. The standard for a kilogram is actually a set of weights that are held in France. This picture is a prototype of one that's held in DC, and It's really close to the same mass, but it's slightly off if you go out like 9 decimals. So with this one, they're actually trying to redefine exactly what a kilogram is to have something that's physically reproducible, where it's not a weight that's kept away in some lab somewhere, but it's actually something that's reproducible in nature. It's also the only one that has a prefix before the name. Is that kilo right there. Okay, so here we have this idea of mass and weight are not the same thing that I kind of mentioned on the last slide. So the British unit for mass is a slug. Again, that's just kind of funny. But the gravitational system, the unit for the gravitational pull on an object or the gravitational force on an object is a pound. And that's what we have a tendency to use. Technically, again, that is a weight. So mass and weight are not the same. Here we have two different astronauts, one on the Earth and one on the moon. And they're saying this astronaut with all of his equipment on, they have a weight of 300 pounds. But on the moon, they only weigh 50 pounds. It's about 1/6. The mass is the same, but the weight is very, very different. And if you took that same exact astronaut and put them on a space shuttle in outer space where they have a micro or gravity or zero gravity, then they would have no weight. They're weightless, but they still have mass associated with them. So mass and weight are not the same. Mass is measured in kilograms. Now, time is measured in seconds. Now, time, I like this definition, is a continuous forward flowing of events. We can't go back in time, no matter how much we would like to sometimes. We can only go forward and we can only go through whatever it is that we happen to be going through. Now, this is based on the rotation of the Earth, or the atomic clocks are actually going to use the vibration of a cesium atom to be able to say what that second is. So when we get to the metric system, um, again, we use the SI system. It's modernized. Mostly it's using the kilogram instead of a gram. The original system actually used the gram as the base for your mass. The advantage, again, we have something that's a decimal or a base 10 system. Very, very easy for conversions. So over here, we have some just basic conversions for you. Now, I'm hoping you're somewhat familiar with that metric system. So on this one, let's see if I can get my pen to write here. Let's try this one. Our base unit would be right here. Now, a lot of times we focus on things that are 1,000 times bigger or 1,000 times smaller. So 1,000 times bigger than a base unit, you would put a prefix of kilo. So if you were going 1,000 meters, you go 1 kilometer. If you have 1,000 grams, that's 1 kilogram. If you go 1,000 times bigger than kilo, you get to mega. And that's a capital M, not a lowercase m. That means that you have a million of something. Now, we deal a little bit with mega when we deal with megabytes. So if we're talking about the memory that a flash drive, so back in the day, back in many years ago, when we had our floppy disk, not the soft floppy ones, but the hard disk, those had a memory of 3.44 megabytes. Now, if you go buy a computer today, you don't buy a computer with megabytes, you're going to deal with gigabytes. Now, gigabytes are 1,000 times bigger than a megabyte. And what's bigger than a gigabyte? I'm sorry, what's bigger than a, yeah, that's right, a gigabyte is a terabyte. And so that's going to be, so we have millions, billions, and trillions. So that's where some of that terminology comes from. Now, going smaller, we also go by thousands. 1,000 times smaller than your base unit, you have milli. This is the lowercase m. So there's 1,000 milliliters in a liter, or 1,000 milligrams in 1 gram. And then 1,000 times smaller than that is micro, that's 10 to the negative 6. And 1,000 times smaller than that is nano. Now we deal with nanometers some when we talk about electrons, and when we get into the light, wavelength of light, we'll talk about nanometers. Now there is one exception on here. There's one that's not based on thousands, and that's centa. Now, I've heard different reasons that we still use centa. We don't use a lot of the other prefixes that aren't based on the thousands, like deci and deca. You may have learned those in grade school. We don't use those a lot. We have them 1,000 times bigger, 1,000 times smaller, because it's easy for us to be able to remember those. But centa is the exception. Now, I think what this has to do with is the ease of measuring small items, the length. So the centimeter is the closest within these ranges to an inch, or to something that's easily manipulated by our hands. So centa is a hundredth of a base unit. So there's 100 centimeters in that meter. So when you're looking at a normal ruler, the centimeters are about yay big and the inches are about yay big. There's 2.54 centimeters in 1 inch. Now, from the 7 base units that we just talked about, we can get derived units. Now, derived units just mean that we're combining different things together. For example, the area of a room is the length times the width. So meters squared, feet squared, whatever. Volume, length times width times height. Now, we're going to talk a little more about volume here in just a minute. Speed is a distance divided by a time. And then we have density. Density is mass, so like grams or kilograms divided by some sort of a volume. So we could talk about grams per cubic centimeter, or we'll talk about later how that's grams per milliliter or liter. Let's hear another one. Now they can get even more complicated. So let's say we take force. Force is mass times acceleration. That's a kilogram times meters per second squared. We start to get some really, really awkward units. So they start to give them some new names. They call this a Newton. And we'll see that again later in this unit. So just something for you to think about. Now, I wanted to make one special note of looking at the idea of volume and where some of this volume terminology comes from. So we're going to use something called a liter. A liter is technically a non-standard metric unit, but let's talk about how it came about. Now, what they did is they took a volume of water. They took a cube of water, 10 centimeters on each side, at its most dense, which is like 4 degrees Celsius, and they found out that a cube of water, 10 centimeters on each side, so it's 10 times 10 times 10, it would have a volume of 1,000 cubic centimeters. There we go, 1,000 cubic centimeters. And they said, okay, we are going to call this something new. We're going to call this a liter. Now, we're probably most familiar with liters when we're talking about, say, a 2-liter bottle of pop. So think of about half of that volume. Now, we have some other cool connections that can be made. So it turns out that that liter of water also happens to have a mass of 1 kilogram. So here we have just a bunch of these great relationships here. I guess the one above it should have been circled too. So 1 liter has a mass of 1 kilogram. 1 liter, based on the prefixes that we know, is 1,000 milliliters, because we know milli means 1,000th. And we know that there was 1,000 cubic centimeters in 1 liter, because that was that cube 10 by 10 by 10. So it turns out that 1 milliliter equals 1 cubic centimeter. So this is a centimeter cubed. Old terminology used to use it as a cc, not necessarily the best terminology, but it's what was used. That equals 1 gram of water. So 1 gram of water, 1 milliliter, 1 cubic centimeter. We have this great relationship that we're going to talk about when we get to the idea of density. Now, if you want to convert it back to the English system, 1 liter is 1.06 quarts, or 1 quart is 0.946 liters. So liters and quarts are going to be very similar in size to one another. So that's a little bit about measurements and a little bit about the metric system. Come back for the next part and we'll talk about how to use these as we start doing some conversions.